This chapter is all about computer networking. Networking means you've connected together two or more computers so they can communicate and share information. A network is made up of several different physical components. Inside your computer, you'll often find some sort of network adapter. If your network adapter uses a wired connection, a network cable will plug into that adapter to connect you to the network. Most modern computers have a built-in network adapter. The standard type of network adapter in today's computers is an Ethernet adapter. If your computer does not have this feature, you can purchase a separate card and add it to your computer later. Sometimes it's difficult to run wires everywhere. If you want to use a laptop sitting on your couch, you certainly don't want wires running through the living room. Fortunately, wireless network adapters or Wi-Fi adapters can be used. These adapters connect to your network using radio signals. Most networks can support both wired Ethernet connections and wireless Wi-Fi connections at the same time. So why not use a wireless connection all the time? Though there are some drawbacks to using wireless connections. They can be slower and harder to configure than a wired connection. In addition, wireless networks have to be specifically secured in order to protect the devices on your network from others who may want to steal your data or spy on your online activity. If you have a hardwired network connection, your network signal is carried on some sort of specialized network cable. Over time, several different kinds of network cables have been created to physically connect computers together. The first type of network cable that was used was a coaxial or coax cable. These are the same cables that you use to connect your cable box to your television. A coax cable has a single copper wire that's surrounded by insulation and other shielding material. These cables are fairly cheap, but they're not very flexible and they are difficult to install. In the 1990s, most network installations switched over to a new network cable, the twisted pair. Twisted pair cables contain up to 8 wires, all wound together in pairs to minimize electromagnetic interference. If you've used a modern Ethernet cable on your computer, then you have used a twisted pair cable. One of the latest types of network cable is the fiber optic cable. Fiber optic cables use tiny strands of glass and pulses of light to send signals to and from the network. Since the strands of glass are so thin, these cables tend to be very flexible and easy to install. In addition, fiber optic cable is capable of faster and more reliable network speeds than coax or twisted pair. Now there are different ways to send data along network cables. Two of the most common ways are called baseband and broadband. In a baseband cable, data is sent using digital signals that take up the entire bandwidth or capability of the cable. These cables are bidirectional, which means the same wire can be used to send and receive data signals. Broadband cables, on the other hand, will send data in the form of an analog signal. This means the signal is separated into individual frequencies, which means you can place more than one data stream on the wire at the same time. However, broadband cables are only unidirectional. That means one channel can only be used to send or only be used to receive. You cannot do both at once like a baseband cable. If you want to do both, you'll have to use two cables or separate the cable into two frequencies, one for sending and one for receiving. So once your network signal leaves your computer and enters your network cable, where does it go from there? Well, from your Ethernet card, a physical wire runs to a central hub or a switch. A hub is a simple device that passes data packets around all of the devices that are connected to it. Each device can decide if the information is meant for that device. A switch is a slightly smarter kind of hub that will only route packets to the specific computer that they're intended to reach. So instead of broadcasting data to everyone, you can more cleanly communicate directly with a target computer. How do your small LANs get connected together into larger WANs or to the internet? You need another piece called a router. A router serves as a gateway between networks. When data comes through a router, the router will examine it and move the data over to the hub or switch for which it's intended. Home LANs have routers also, and these routers manage the basic network infrastructure for each of the connected computers. The routers may be smart enough to connect directly to an internet service provider, or they may use a modem to obtain a connection to the internet. A wireless network adapter will connect to a central wireless access point near the router using radio signals. The wireless access point is often built directly into the router itself, so your LAN can support both wired Ethernet connections and wireless Wi-Fi connections.